Hello and welcome to another NGen Math 6 video by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11cc, Lesson 10 on Analyzing Results. So this is the last lesson in our statistics unit. And honestly, at the end of the day, right, in statistics, where we began is sort of where we end, which is that we want to answer statistical questions. And when you answer statistical questions, it's not like a yes, no kind of thing. That's not the deal. When you answer a statistical question, you give evidence to sort of support your answer. And that evidence can be evidence in terms of central values like mean, median, mode. It can also be in terms of measures of variation like range and interquartile range, right? So what we want to be able to do is we want to be able to summarize what we've collected in terms of data in order to answer a statistical question. So we're just going to briefly look at that in today's lesson. Let's get into it right away. When answering a statistical question, it's important to be able to use the measures of center and measures of variability to summarize what the data we collect tell us. All right, well, let's take a look at kind of a case study. Exercise 1. Malia is trying to answer the following question. How many hours of sleep do kids in my class get on a weekend night? Why is this an example of a statistical question? All right, so pause the video now and make sure you can answer this important question about statistical questions. Well, there's so many different ways to answer it, right? You know, you can get technical by talking about variation in the data or differences in the data, right? Or you could just say it, you know, obviously. Different students get different amounts, let me just move this really quick, of sleep, i.e. there is variation in the data, right? And that's what it really boils down to, right? There is no single answer, right? So if all kids always got 8 hours of sleep on weekend nights, all kids, everywhere, always, then the answer would just be 8, right? That would be the answer, right? But because different students get different amounts of sleep, and you could even say the same student gets different amounts of sleep on different weekend nights, right? You know, because of that, there's variation in the data, and because of that, it's a statistical question. All right, so let's kind of keep going on this. Exercise number 2. Malia asks each student in her class to record the number of hours of sleep they get on a Friday night into a Saturday morning. Each student is asked to round their amount to the nearest half hour. The data is shown below in ascending order. Create a dot plot of the data on the number line below. All right, well, why don't you go ahead and do that? Create that dot plot on the number line below, and then we'll go through that. All right, awesome. Let's do it. So simple enough, right? We're just going to put dots every place there's a data value. So we've got 1 at 7. We've got 2 at 8. We've got 2 at 8.5, 1, 2, 3, 4, 5 at 9, right? 1, 2, 3, 4 at 9.5, 2 of them at 10, right? 1 at 10.5, and 1 at 13. Okay? So there's our dot plot. And again, like all statistical graphs, right, what the dot plot is there for is to sort of give us a sense, a visual picture for the data that we're going to use to answer our question. And of course, what you want to do almost immediately whenever you have a visual representation is you want to do something like exercise number 3. So let's take a look. Make some observations about the distribution of the data based on the dot plot. All right. Well, there's lots of observations that you could make, right? Why don't you pause the video and make just a couple of observations about what you see in the data as given by the dot plot. Right? Well, one thing that you could say is something like, many students got either 9 or 9.5 hours of sleep. Many students got 9 or 9.5 hours of sleep. So that's one thing. And that kind of gets at the idea of a central value, right? A value of center, like the mode or the median, something like that, or even the mean, right? You might also want a little bit of variation, right? The greatest amount was 13. The least amount was 7. So one real easy measure of variation that we could throw in would be the range, right? And there was a range of 6 hours in our data set, right? To go from 7 up to 13 would be 6 hours. So maybe I'll throw that in as well. There was a range of 6 hours. All right. I mean, we could get deeper into it, start to do some real calculations in terms of the median and the mean and whatnot, but just, a few little observations based on this dot plot, just to start to get a feeling, right, for what the answer to our statistical question is. All right, so let's take a look at exercise number 4. The data set that Malia took is reproduced below. Find the 5-number summary and create a box plot on the number line below. All right, so let's recall what the 5-number summary is. And we saw this earlier in the unit, right? And what a box plot is. We saw this earlier in the unit, right? The 5-number summary is the minimum value. That's going to be easy. That's 7. And the maximum value, that's easy. That's 13. Why don't we write those two down right away? So the min equals 7. And the max is equal to 13. Those are always the two easiest ones of the 5 numbers, right? Now the other 3 numbers are the median, the first quartile, which is the median of the lower half of the data, and the third quartile, the median of the upper half of the data. So let's first find the median. Now, how many data points did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. Now I lost count. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let me write that down right here, right? There are 18 total values, okay? So to find the median, what we're gonna do is we're gonna divide the lower 9 and the upper 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And that's easy then. The median would be the average of these two, but the average of 9 and 9 is just 9, right? Now, keep in mind, now if we're trying to find the lower quartile or the first quartile, what we're going to do is we're going to look at this lower set of 9 data points. Sorry about all these 9s, but of these 9 data points, and we're going to find the 1, 2, 3, 4, 5, the 5th one, right? So that's going to be our Q1, our first quartile, is going to be 8.5. Then we're going to do the same up here, 1, 2, 3, 4, 5. Right, our Q3 is going to be 9.5, and there's our 5-number summary, right? Our minimum value, 7, our maximum value, 13, the median of 9, the first quartile value of 8.5, you can almost see that decimal point, not quite, 8.5, and our third quartile value of 9.5. Now, how do we make that box plot? Okay, remember we're going to put some lines on here. So I want one line at 7. I'm going to put another line, my maximum, at 13, right? Our median at 9. Our first quartile at 8.5, very close. Our third quartile at 9.5. Here comes our box. And then we're going to extend out what used to be called whiskers out to those end lines. All right. Remember, some teachers will say not to put these little final lines on there. They'll just have you kind of extend that out and have the line stop there and there. I like having those nice vertical lines there so you can really see your minimum value, your maximum value, your first quartile, your second quartile, also known as the median, and your third quartile. All right, so we've got our box plot, we've got our 5-number summary. Let's take a look at exercise number 5. Malia sums all of the data and finds a total of 166.5 hours. Which statistical measure of center for Malia's data set is larger, the median or the mean? Justify. All right, this may take you a little while, so pause the video now and see if you can figure out which of the two measures of center was larger, the mean or the median. Pause the video now. Well, we already know what the median is. Let's write that down, right? From before, we knew that the median was equal to 9. So I'm just going to write that down. Didn't quite work. The median is equal to 9. Now to find the mean though, we're going to have to do a little division. Right? The mean is going to be our total, 166.5, divided by how many there are, which is 18. Okay? So I now have to do this division longhand. So I have to think about it a little bit. I'm gonna go with 9 right away, right? To see, because I know my mean and my median are going to be close together. So 9. So 9 times 8 is 72. Bring up the 7. 9 times 1 is 9 plus 7 is 16. Subtract. Bring down the 5. Put that decimal point there. 18 goes into 45 2 times. That's going to be 36. Subtract. We get 9. Tack a 0 on here and bring it down. And then 5 times 18, I believe, is 90. 0, 40, and 90. All right, so the mean is 9.25, which means that the mean is larger. Just barely, but it's a bit larger, right? The mean is 9.25 hours, the median is 9. Now, by the way, the reason that the mean might be a little bit larger than the median is because of that 13 that's way out there, right? That person who really slept in and got 13 hours of sleep. You know, they went to bed at like 10 o'clock at night and got up at 11 o'clock the next morning, or 8 o'clock at night and got up at 9 o'clock the next morning. 13 hours of sleep is almost inconceivable for me, but it can happen. Let's take a look at exercise number 6. Is the maximum or the minimum value for this data set closer to the median? All right, well, think about that a little bit. You know, which one's more extreme? That maximum at 13 or that minimum at 7? Take a moment and think about which one is closer to the median, the maximum or the minimum value. Well, you can actually see it right on our box plot, right? So the minimum is this far away, right? Which is actually 2 units or 2 hours, right? The maximum is this far away, right? Which is actually 4 hours. So the minimum is closer to the median. Okay. Now finally, right? Exercise number 7. Answer Malia's question by giving a summary of this data set. Include in your summary a statement about both the central value or values of the data set, as well as the range of typical values. Okay. So in other words, right, Malia has set out to answer a question. How many hours of sleep do students in my class typically get on a weekend night, right? now is where you would answer it with full sentences, and those full sentences would include measures of center, measures of variation, etc. And notice here they talk about the range of typical values, right? So that should, especially typical, right? That should give you a little hint what we're looking for there. Pause the video now and try to write down a summary that answers Malia's question. All right. Well, oftentimes you start off with something that has a center of value in it. We could use the mean of 9.25 hours. We could use the median of 9 hours. Either one is fine. We could use them both. So we could say the mean hours of sleep was 9.25 hours, and the median was, there's my red pen, and the median was 9 hours, right? So we always want to have some kind of statement about the central value, and if you can put them both in, why not, right? And now we want to talk a little bit about the variation. Now it says typical values, right? So I'm not so certain that that minimum of 7 and that maximum of 13 are very typical, right? Those are the kind of outlying values, not necessarily outliers, but they're the ones that are kind of the most extreme, okay? The typical values we tend to think of as being that middle half, right? That half that's within the box. And the range there is only 1 hour, right? Right, that's the IQR, the interquartile range. And that just goes from 8.5 hours to 9.5 hours. Half of our data set is falling, right? Within that span, right? So we would then maybe say the interquartile range was only 1 hour, and maybe I'll throw in the actual range, while the total range was, whoops, was 6 hours, right? And that gives us a beautiful summary that answers Malia's question. And that's the thing about statistical questions, right? They don't have just a single answer. They don't have something that's clear cut like, okay, what is the tallest mountain on Earth? Oh, it's, Mount Everest at, 42,000 feet tall, right? It's not a simple answer like that, right? Because of the variation in data, right? You have to talk about central values and variation and things like that. How much sleep do students typically get on a weekend night? Well, on average around 9.25 hours, with about 1 hour of variation amongst the middle 50% and a total variation of 6 hours, or a total range of 6 hours between the minimum and the maximum, right? That really gives us a good sense then for how much students are sleeping per night on a weekend night, at least in Malia's class, and at least on this one night. All right. So let's summarize, right? When answering a statistical question, okay, you almost never can give just a simple, straightforward answer. You almost always are going to summarize your data using a measure of center, typically the mean or the median, and then some type of measure of variation. Most often, the interquartile range is the best measure of variation to use simply because you're talking then about that middle 50% of the values, and you don't really get into those really high ones and those really low ones, right? And that's it. And that's our unit on statistics. I want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.